Hello everybody, we are back with another visual pattern challenge. So here is our pattern. Here's step 1 in the pattern, here's step 2, here's step 3. And the challenge, if you want to accept it, is to figure out how many hexagons are going to be in step number 4. And then if you can, much more difficult, how many in step 43? And can you write an equation to figure out how many hexagons in any step at all? So if you'd like to take that challenge, pause the video, give it a try. All right, so let's see if we can just figure out visually what's going on here. I see 4 hexagons in this first step, and let's see, there are those 4, so it looks like those got added. And let's see if I can see this pattern in here. That would be that much. So it looks like those got added again. So it looks like we're adding 3 hexagons onto the end each time. So I think it's going to be a linear pattern. I think we can use this adding 3 knowledge to predict the next one. So we'd have a hexagon here and one here and another one down here. So we'd have 3 more. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 hexagons in step 4. So I think that's what we'd see in the next step. But let's analyze this pattern a little bit. Let's look at the numbers. I'm going to make a chart with the step number and the number of hexagons. So in step 1, there are 4. In step 2, there are 7. In step 3, there are 10. And we're predicting 13 for step 4. And then we're going to look at the difference between the number of hexagons in each step. So 7 minus 4, the difference between those two steps is 3. 10 minus 7, 3 again. 13 minus 10, 3 again. And that bears out what we saw visually. We seem to be adding 3, going up by 3 every step. When the difference is the same, when the change between each step is the same, we call that pattern linear. And we can use the equation of a line to model it. So we'll use this. And in this equation, the m stands for slope in a visual pattern. It is the change, the rate of change from step to step. So the m is going to be the 3. The x is our step number. And the plus b is whatever else we need to add or subtract to make it work out with the number of hexagons that are actually there. So let's try step number 1. So y would equal 3 times step number 1. I'm putting the 1 in for x. And if I left it at that, 3 times 1 would be 3, but I've got 4 here. So it looks like I'd need to add 1 more to make 4. So we can put 1 more here on our formula and on our equation and call it 3x plus 1. But let's test to make sure that actually works for step 2. So this would be y equals 3 times step 2 plus 1. So that would be 6 plus 1 would be 7. That's 7. If we tried it with step 4, it would be 3 times step 4 plus 1. That would be 3 times 4 is 12 plus 1 is 13. That bears out our prediction. So I think our equation is y equals 3x plus 1. Now we can use that to get the number in step 43 pretty easily. We just put in 43 in place of x for our step number. So we have y equals 3 times 43 plus 1. So 3 times 43, let's see, 3 times 40 is 120, 3 times 3 is 9, so that's 129 plus 1, that is 130 hexagons in step 43. Well, how did you do? Did you get step 4? Did you get step 43? Let me know. Thanks, everybody.